subtopic number 3, which is on thin lenses. So you have, in this subtopic, we have to be able to use the thin lens equation for real object only. And next we have to determine the focal length of, so this one is for your experiment. Not sure if we're gonna do experiment or not, but this is experiment punya lah. Next, use lens maker's equation, which is this one here. Apply magnification. And lastly, use the thin lens formula for a combination of two convex lenses. Okay, so what is thin lenses? Thin lenses is basically a transparent material with two spherical refracting surfaces, which their thickness is thin in comparison to the radii of curvature of the two refracting surfaces. For example, contact lenses. Okay, that's why it is called as lenses. So we have convex and concave lenses, where convex lenses is the one that is thick in the middle, whereas concave is the one that is thin in the middle. Okay, so we call this as biconvex lens. This is plano-convex lens. This is positive meniscus. This is biconcave lens, plano-concave lens, and this one is negative meniscus. Okay, so basically you need to know what is the shape of the lenses lah, if dalam soalan dia bagi the word saja, right? Okay, so these are the terms used for thin lenses. We have principal axis, which is the line through the center of curvature C1 and C2, and then center of lens, which is O, a point where all rays pass through this point, which then continues in a straight line. Radius of curvature R, which is just the radius of the sphere of which the surface of the lens is a part. So this is one sphere, this is two sphere. Gitulah. Okay. Right, so the radius is, I forgot to add the label. So this is R lah. Okay, so that is your radius of curvature. Next, we also have focal point for lenses. That is the point where the parallel rays incident on the lens either converge ataupun diverge. Okay, converge after refraction is for convex lens, diverge is for concave lens. The focal length is the same. It is the distance between the focal point and the center of the lens. Right, so that is the terms that you need to know for lenses. Next, let's try to sketch a ray diagram to obtain image formed by concave and convex lenses. Right, so this is a convex lens. Sama juga, we just have to locate the position of the object, the focal point, and the center of curvature of the lens. But for this one, the center of curvature is quite big, so it's kind of somewhere here. Ataupun di sini lah, begitulah. Right, so let's draw the ray. The first ray is from the top of the object parallel to the principal axis, and then it goes through the focal point. Something like that. Okay, so don't forget your arrow. And then do for the second one. So I'm just gonna do OFP, which is from the top of the object through the focal point, and then it goes like this, parallel to the principal axis. Okay, so this one should be a bit longer, just so that they intersect. Okay, so that is the two rays. Two rays are enough, or you can also add object, center of curvature, and then like this. So basically they intersect at this point here, and since it is below the reference line, it's gonna be pointing downwards, and then that is your image. Okay, so clearly we can see that this image is much more bigger than the object itself. So let's write the characteristics of the image. Firstly, we can see that it is inverted because it has a different orientation as the object. So let's just write inverted here. And then it is behind the mirror. So if it's behind the mirror, it's gonna be backside of the lens, which is oh sorry, I keep saying mirror, it should be lens. Okay, so it is formed at the back side of the lens, so it is a real image. So just write there as real, and then since it is much more bigger than the object, this image is magnified. Okay, so your characteristics is based on your drawing lah. Kalau tiada drawing, it is based on the magnification dengan the image. Macam tu. Right, so this is the ray diagrams for convex lens. Again, you have to do this one yourself. Also list down the characteristics that you can see from the image lah. Okay, next let's do for the concave lens. So this is a concave lens, and also start from the object parallel to the principal axis and then go through the focal point. So it goes through the back punya focal point lah, bukan yang di depan tu. Yang this one here. Okay, so it's gonna be this way, and then it is gonna be refracted parallel to the principal axis. Oh sorry, wait, this is OFP. Oh okay, salah. Ni untuk concave dia berbeza dengan convex lens. So for concave lens, this is where the ray diverge kan. So if it diverge, it's gonna be going through this focal point yang di depan. Okay, so it's gonna be like that, and then since this is at the front side of the lens, this should have a dashed line. Okay, if you see the ray diagrams for convex and concave are different lah. Okay, let me just make it a little bit smaller. Okay, oh dia boleh sudah. Coba, this one should be just like that, and then let's just draw the arrow, and then they're refracted this way. This is refraction button. Yeah, refraction. Okay, lepas tu this one front side ni kamu mesti buat dash line lah. Okay, sebab front side is a virtual, so mesti dash line. And then second way that we are gonna draw is from OF. It's gonna be OF, and then from here I'm just gonna use a different color. So OF, and then at here it is refracted back to this point here. Something like that should be fine. Okay, so arrow, jangan lupa lukis like this. Okay, so untuk this second ray, it's gonna be dash line will be from here, right? So these two rays have a different dash line lah, satu di front, satu di back side of the lens. Okay, so always remember untuk first ray, it will go through the first focal point, which is the front punya focal point, and then the second ray, it will diverge from the back punya focal point lah, right? So where do they intersect? They intersect at this point here. So this is above the reference line or above the principal axis. So that is going to be pointing upwards, and this is your image. Right, so from there we can then state what is the characteristics. So since it is formed in front of the lens, the image is going to be virtual. Okay, and then it is upright because it has the same orientation as the object, and then it is diminished. It is much more smaller than the object lah. Okay, so that is for the concave lenses. Right, untuk concave lenses, basically dia punya lukisan untuk ray diagrams is basically just like this. And then for convex lens saja yang dia ada perbezaan. Okay, so this is the equation for thin lens. This is only for real object lah. So object tu mesti positive. And then this is just the ray diagram. What else? So the magnification is similar to the mirror. And then again, we have to know the sign convention lah. So the object will be real if it's positive, virtual if it's negative. Okay, the image distance, it should be at the back side of the lens for it to be positive, and front side it's gonna be a negative value because it is a virtual image. The focal length for a convex lens will be positive, whereas for a concave lens it would be a negative value. The magnification, if it's positive, it is telling us that the image is upright, whereas negative is inverted lah. Okay, so this table jangan confuse dengan the spherical surface and the mirror. Okay, so these three are different. Right, so now let's look at the lens maker's equation. What is this equation? This is used to find the focal length of a lens. Okay, so this is the equation. And then the sign convention, this one shown here lah, untuk radius of curvature. For convex lens, it would be positive, concave, negative, infinity. Maksudnya dia akan flat. It is a flat surface, which is plane. Okay, this is a plano, which is gonna be at infinity lah. Okay, so now this is just the definition of, no, not the definition, the name of each of this quantity lah, right? So this is the radius of curvature for each type of lens. So kalau biconvex, dia tulis sini convex masih positive, so that's why this here is convex, but then this side here is gonna be negative because light is from here towards here, so this is a concave lens, so that's why di sini dia jadi negative. Kalau kita tengok light from here, this is a convex, so it's gonna be positive, and then light goes from the left to here, looking at a flat lens, so it's gonna be at infinity lah. Okay, sama juga yang macam ni lah. Right, so kamu bukan tengok dari sini, and then dari light is you are gonna look at the light from left to the surface here. Okay, it's not gonna be from right to the surface here unless the question mentioned that it is on the right side. Macam tu lah. Okay, right, so lenses in combination. So lenses in combination states that the image on the first lens would act as the object for the second lens. So ini bila soalan dia sudah suruh kamu cari the image formed by this object, dia ada jadi image di sini. So image ni pula akan jadi object for this second lens. Okay, so this is what it meant by lenses in combination. Okay, so these are the steps, but you have to kind of do problems that relates to this in order for you to understand it lah. Okay, tapi the first step is you have to ignore this lens and just focus on this one lens here. After that, the image that is formed due to the lens here would become the object for lens number 2. Okay, lepas tu barulah kamu boleh cari the final image formed by this lens, and then that's it. So that's just how you do lenses in combination. The total magnification pula adalah the product of the magnification of each lens lah. So this have its own magnification, these two. Okay, so magnification due to lens 1, you just have to calculate using the value of the object distance dengan the image distance untuk lens 1 lah. Untuk lens 2, buat macam lens 2 juga. Okay, alright, now let's look at an example. So we have a person of height 1.75 meter So it is the person is standing 2.5 meter in front of a camera. So this is the height of the object. This is the object distance. Next, the camera uses a thin biconvex lens. So biconvex lens is gonna be begini. Okay, so this is a biconvex lens and light comes here. This is a convex, so it's gonna be positive, and then light goes here. This is a concave, so this is negative radius of curvature, right? Okay, lepas tu that is the radius of curvature, so they have the same radius of curvature lah. Okay, so that is R. The lens is made from the crown glass of refractive index 1.52. So we have to calculate the focal length of the lens. So how do we do that? We are going to use the lens maker's equation, which is 1 over f equal to n of the material over n of the medium minus 1 over R1 minus 1 over R2. So this is the lens maker's equation. So it can either be capital R ataupun lowercase r. But here I'm just gonna use capital because I've wrote that as capital R in my notes. Okay, so sekarang ni what is the material punya refractive index? It is 1.52. So this is an material. So this is basically they are in air lah kan. So mestilah di udara. So this is the medium punya refractive index. So medium punya refractive index is just the air punya refractive index, which is 1.00. Next, the radius of curvature. R1 is the convex lens. So convex lens should be positive. So it's going to be positive 7.69 times 10 negative 3 meter. The radius of curvature for the second surface, which is a concave surface, will be negative 7.69 times 10 negative 3 meter. Right? Okay, so that's about it. We just have to substitute the values in order for us to find the focal length. So 1 over f is equal to 1.52 divided by 1.00 minus 1 over, okay, that's a lot of numbers, minus with negative 7.69 times 10 negative 3 divided by 1 here, divided by 1 divided by that thing. Okay, so kamu akan dapat the focal length to be equal to positive 7.39 millimeter. Okay, so that is how you solve for focal length using the lens maker's equation. And then next we have to determine the position of the image and its height. So the position of the image and the height, we can use 1 over f equal to 1 over u plus 1 over v. Okay, so kenapa kita mau cari ni? Kenapa kita guna equation yang ini is because we are looking for the image punya position, which is basically the distance of the image punya distance lah. Okay, so focal length kita sudah ada, which is 7.39 milli equal to 2.5, 1 over 2.5, which is that one there, and then plus with 1 over v. So from here you will get the image distance to be equal to positive 7.41 times 10 negative 3 meter. Okay, so since this is a positive value, the image is formed at the back side of the lens. Okay, so that's just what you need to know. Ada ka datanya? Position. Okay, position is back side lah. Kamu tulis back side of lens. Okay, kamu tulis macam tu je. Lepas tu kita perlu cari the height. So how do we calculate the height? We can use the magnification punya formula, which is, that is just m equal to hi over h naught equal to negative v over u. So we don't have the magnification directly, so we just have to use these two formula here lah. Okay, so dari situ kamu akan dapat hi equal over 1.75, which is the height of the object, negative 7.41, negative 3 divided by 2.5. So kamu akan dapat the height of the image to be equal to 5. Let me just check if it's gonna be 7.41 negative 3 divided by 2.5 times with 1.75, so it's gonna be negative 5.19 millimeter. Okay, so you can either write it as just keep it this way lah. Okay, tapi tukar apa lagi. Okay, lastly we have to state the characteristics of the image. So where should I write that? So I'm just gonna write it here lah. The characteristic of the image is, first we know that the image is formed at the back side of the lens, so that is a real image. And then next, since the what else do we know? Form at the back of the lens is just basically telling us that the image is real. And then the magnification, we can know the characteristics of the image based on the magnification. If you do that, you can know that it is gonna be inverted, and then lastly it's gonna be diminished. Why? Because we know that the height of the image is much more less than the height of the object, which is 2.5. Okay, diminished, inverted, and real. These are the characteristics of the image. Next, example 5. We have a biconvex lens made of glass with index of refraction 1.6. Okay, so this is the material punya refractive index, has a radius of curvature of 30 centimeter for one surface and 40 centimeter for the other. So if you were to draw that, we have biconvex like that, and this is gonna be R1, which is 0.3 meter. So it's gonna be positive lah sebab dia convex. R1 is positive 0.3 meter. And then this is a concave, light goes here, so this is a concave punya lens, so that is R2 equal to negative 0.4 meter. Okay, so what is the focal length of the lens? Just use the lens maker's equation, 1 over f n material over n medium. So it didn't mention whether we are in other medium, we just assume that this is in air lah. Okay, so that is 1 over R1 minus 1 over R2. So the material refractive index is 1.6. 1.00 is for air. 1 over 0.3 minus 1 over negative 0.4. So your focal length will be equal to 28 point. I'm just gonna use meter lah. So that is 0.286 meter. So that is the focal length. So it's gonna be positive 0.286 meter lah. Right. So if the lens is immersed in water, is there a change in the focal length of the lens? If so, which way? Okay, so when immersed into water, the focal length will change. So focal length will change. So why will it change? Because F here depends on the index of refraction of the surrounding medium. So it depends on the refractive index of the medium. Kalau the medium change, mestilah the refractive index pun change. Lepas tu, the focal length, when the refractive index of the medium is greater, so when the refractive index of this medium is greater, the focal length would also be greater because they are basically proportional to each other. Okay, so kalau kamu tengok ni, they are proportional to each other. Right, so that is basically the explanation lah kenapa dia ada perubahan. Next, we have to calculate the focal length if the lens is used underwater, which I didn't put the refractive index. So the refractive index for water is gonna be I'm just gonna put as medium apostrophe. So this is underwater, 1.33 lah, the refractive index. So from here we just have to again use the lens maker equation. So n material over n medium minus 1 over R1 minus 1 over R2. So yang ini material masih sama, which is 1.6. This is 1.33 minus 1. This is 1 over 30 meter. We are going to use meter. Okay, so kamu akan dapat the focal length to be equal to 0.845 meter. Okay, so that is the focal length. So as you can see, the focal length does changes when the lens is used under water. So the focal length is much more greater than when the medium is air. Right, so that is how you solve problems using the lens maker's equation. So what you need to know is basically know the sign convention for a convex and concave and flat surface, right? You don't really have to memorize all this. You just have to know the radius of curvature punya sign convention yang tadi cakap lah. Okay, right, so that is all for subtopic number 3.